Most people fail in the cloud because they don't understand the network. They launch servers in a default VPC and leave their databases exposed to the world. Today we change that. Welcome to day 06 of 100 days of AWS. We are designing a production grade VPC from scratch. So let's dive into it. Here we have designed a whole architecture. Now we will go step by step through it. So first of all, there are two sides of VPC. One is public subnet and one is private subnet. So I've already explained in my previous video what is public subnet and what is private subnet. I will attach the link. Kindly check it out. So public subnet is our front porch where our web server lives. It is a direct connection to the internet gateway, which is the front door or our VPC, through which internet traffic can come in and hit our EC2 instance. So public subnet is exposed to the internet through internet gateway. Now the question arises, how the internet gateway routes the traffic to the public subnet EC2 instance. Here we will use route table. Route table is basically a pathway or a hallway to your house, which is our public subnet. So through internet gateway, traffic will come in and route table will route the traffic. And to allow that, we will update the security group with HTTP 80, which is the 80 port for HTTP request and SSH for 22 to log into the server. Now it is exposed to the public, but what if there are applications like databases or private application which did not to be exposed to the internet, where private subnet comes in place? Here we do not expose our application to the internet. Here we will create a EC2 instance in our private subnet, which will be locally. It doesn't have internet access and it will just do operations locally. Here if we want to access the EC2 instance, we are providing security web group as allowment, where we will allow security group WebSG, which is security group for the web server, so that if we are logged into the web server, then only we can SSH into the app server. And we'll attach a private route which will be local to VPC, so that traffic will flow only in the VPC, not outside the internet. So let's again summarize the traffic flow. So suppose a user hits our URL, so it will come through internet gateway. Internet gateway just acts like a door between the EC2 instance and the internet. It will allow the traffic, and to map the traffic or to route the traffic to the EC2 instance, public route table will act as a hallway or a road kind of, which will allow traffic to move to the EC2's instance and hit the response back. Here we will allow SSH and HTTP request in security inbound rules. Then we have our second part, which is private subnet, where only the EC2 instance, which is our web server, can only access the application. No outside traffic is allowed. That's why our private route table or hallway is only allowed locally in VPC. And also, to make it more secure feature, then that's why we are allowing AppSG security group for SSH and from the web security group only, so that this EC2 instance can only SSH into the server. So we will assign a CIDR group to our VPC. So we will talk that in the next section, which is going to be now. Let's move it to the next section. So yeah, here I have already pasted the link in the chat for the GitHub repository, where you will find all the needed documents. So let's start. Now we have different components which I have already explained to you, where what is VPC, private subnet, public subnet, and the internet traffic flow. Then we will talk about the CIDR, the IP you have seen in the architecture previously, what it is, and it is very difficult concept, but I will make it easy for you. So to build a network, you must understand the math behind the addresses. It is very true. So if you create a VPC, you need public IP address as well as private IP address. So to get a private IP address, we define a CIDR block. So CIDR is basically classless inter domain routing. So it is the full form of the CIDR, classless inter-domain routing. What it does is it provides a fixed notation of IP addresses. Suppose here we have taken 10.0016/16. So the number slash after slash tells you that how many bits are fixed for the network part of IP address. So suppose for the IP 10.0.0.0/16, here if you see there are uh, four octet, so we call the single as a octet. So every octet is assigned with 8 bit. So this first one is 8 bit, 0 is 8 bit, so every octet is 8 bit. That's why whole IP address will be of 32 bits. So whole IP address is of 32 bits. So here we are saying first 16 bits are fixed, it can't be changed. So here 10 point from 10 first to octet will be fixed, and we can only change 0 to last two zeros. So our IP addresses will become from 10.01 to 10.0 dot 225 to 255. So I will paste first 10 IPs of the VPC. So it will start from 10.000 to 10.001, 2, 3, etc., etc., and I will paste the last 10 IPs. So last 10 IPs will look like this. So last IP will be 10.0255. So how, how to count number of IPs? So it's basically simple math. Here if you do 255 into 255 permutations, so it will be 255 into 255, which will be equal to 65536. So it will give us 65,536 IPs. So from 10.001 to 10.0255255. Now if we come to this IP, which is of our public subnet, so from here inside the VPC we need, after 65,000 we need 256 IP. How we got 256 IP? Just let's just calculate it. So here I will paste the link, sorry, the IP address. So here we are fixing the first 24 bits. So 8 into 3 is 24. So we will fix the first three octets. So here we are fixing 10.0.1. Only the last one will change. So if we look at the first 10 IPs, so it will be look like this. And if you go with the last 10 IPs, I'll just scroll it here. Last 10 IPs will look like this. So it will start from 10.0.1.0, then it will end on 10.0.1.255. So the first three octet will be fixed and the last one will change from 0 to 255. As you guess, from 0 to 255 we will have 256 numbers. Similarly for this one, we will, as it is /24, so first three octet will be fixed. We'll start from 10.0.2.0 to end 10.0.2.255. Remember, these are the last and this is the first one. So here we will get 256 total IP address. Now, which I already explained. Now the catch is, for the first four IP addresses and the Last one IP address in every subnet are reserved by AWS for networking. So /24 gives you only 251. From here, 5 IP addresses will be assigned by AWS to their internal DNS and gateways thing. Now, as I already explained, in web security group, we will allow HTTP traffic for 80 port, which is all over the world, and SSH through our own laptop IP or PC IP. And for app security group, our private instance, we will allow only SSH from the public EC2 instance. And in the result, a hacker cannot SSH into our app server even if they have the key. They must go through the web server first, which acting as a bastion host. Bastion host pattern is like keeping our application server isolated from the internet traffic. Yeah, so that's all for this video. In the next video, we will implement the production grade VPC architecture. So kindly stay tuned with me, and I will provide the GitHub link in the description to grab the architectural diagram and the CIDR cheat sheet.